Hello, lovely people. What is up? Today we are solving Leetcode problem number 1080. Find unique binary string. So, in this question, we are asked to give an array of string num containing n unique binary strings, each of length n, and we are asked to return binary string of length n that does not appear in nums. If there are multiple n's, we can return any of them. So, what we are given is a binary array of binary strings of length n, and we are asked to find any binary string that is not inside nums. So for example, let us take nums is equal to 0 1 and 1 0. So the possible strings of length 2, because 0 and 1 the length is 2, that is n. So possible strings of length 2 is 0 0 0 1 1 0 and 1 1. Since 0, 1 and 1, 0 already exist in our given nums array, we should return either 0, 0 or 1, 1. So this question can be solved in two approaches. One is backtracking and the other is diagonal check. So in backtracking, we generate all possible binary strings of length n and return the first one not present in the array. So we store all given strings in a set for first lookup and then generate binary string using backtracking. If a generated string is not in the set, we return it. So when we are coding it, we first get the length n is equal to len of nums. So and then we convert the list to set, because checking inside a set is very fast. So scene is equal to set of nums. And then we build binary strings character by character. At each step, we have two choices, either add 0 or add 1. Now we define the backtracking function, def backtrack, and the parameters are start comma current. So start comma current. So these two variables, start counts how many characters we have built, and current counts the current binary string that we have built. And then we define an if statement for the base case. If start is equal to n. This means we built a complete binary string. And then we check if current not in scene. So if the string does not exist in nums, we have found the answer. So we return it. We write return current, and then outside of the current if statement, we return an empty string. Return empty string. And then we initialize a for loop to try both digits, like for ch in list, that is square brackets 0, 1. Both 0 and 1 are characters. If it is true, we grow the string. Next, we build the next string. So a variable result res is equal to, we are calling the function backtrack of start plus 1, current plus character. And then we initialize an if statement if answer is found. If res result is not equal to empty string, we return result. So if nothing works, again outside of the loop, we return a empty character, empty string, and then we start the recursion. So we return backtrack of 0, empty string. So the time complexity of this particular code is O of 2 power n, because we generate all binary combinations. For a better time complexity, that is O of n linear time, we can use the diagonal trick. We can use the Cantor's diagonalization thing. The idea is to change the ith bit of the ith string. So basically, we are building a new string that differs from the ith string at the ith position. If our string differs from every string in at least one position, then it cannot be equal to any of them, and then we get the answer. So if we take a look at the code, we are initializing a new list result. So res equal to new list square brackets. And then to loop through each string for I in range of length of nums. This loop runs for each row. And then we look at the nums of I and I. So we write nums of I and I. This means ith row and ith column. We are using a matrix type thing. So we are always checking the diagonal position. And then we flip the bit. So we use an if and else condition. If nums of ith row and ith column is equal to character 0, we append it into our result. Res dot append character 1. Else we append 0 to res. Res dot append character 0. So here we are simply flipping the bit. Then finally we are returning string dot join result. So return quotation dot join of res. So as you can see, this code is running in the most optimal time possible. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.